The following program is video supplemental instruction. VSI is brought to you by the Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.
I'm going to work through problem 4 in Physics 2020, the midterm for exam 1. And actually in this problem is actually a continuation of problem 3. And so I recommend, if you are having difficulties with this problem, to go and review problem 3, the video for problem 3 that we worked through. And so in this particular problem it says, when the diver hits the water, what is the horizontal distance back to the point where she left the platform? And so basically from problem 3 we know that we have a diver standing on a platform that is 3 meters from the water, and that this diver dives out with an initial velocity of 5.0 meters per second. Okay, and we know that this diver, once she dives out at an initial velocity of 5.0 meters per second, she's going to hit the water at some point. And we know that the time it takes for her to reach the water was 0.78 seconds. That was the time that we found in problem 3. And so in this problem, it's asking us to find out what is the distance that this diver actually traveled during her dive. So from the point where she hits the water back to the actual point on the platform, what is that distance? And so in order to solve this problem, we need to understand some things. Okay, the fact that this diver is diving horizontally means that our initial velocity is in the horizontal direction only. There is no y component. So we know that the initial velocity is equal to the initial velocity in the x direction only, which is 5.0 meters per second. Okay? We also need to know that for projectile motion, gravity is only acting on an object in the y direction. Okay? And so that means that when you have a velocity in the x direction, that velocity in x direction is going to remain constant, because if you neglect air resistance, there is nothing there's no force on the object that's causing the velocity to change in the x direction, and so the velocity remains constant in the x direction. So this is constant. Okay, so it's always going to be 5 meters per second throughout the projectile motion. Okay, another thing we need to know is that since the gravity is only acting in the y direction, the time it takes for the object projectile to hit the ground, to hit the water, is going to be the same time it takes throughout the projectile motion as if it were just dropped from that single position. Okay, and we found that time to be 0.78 seconds. So, understanding this information, we can go to our formula sheet, and we know that we don't need to look at projectile motion anymore, since we're talking about it's moving with constant velocity. And we want to find the distance back to the platform. So two things we know basically, if the velocity is constant, then basically that's the average velocity throughout the flight. So we know the average velocity, and we know the time. Okay, so we want to find what is the distance. Well, if we go to our formula sheet, we can look at something, a formula that has these 3 components in it, and which would be the average speed. And so in this particular case, we're talking about the x direction, so the average velocity in the x direction is equal to the distance that it travels in the x direction divided by the time. Okay? And we can simply solve this equation for x to get x is equal to the average velocity multiplied by the time. Okay? So this is our formula that we choose from the formula sheet. And we can simply calculate now by doing direct substitution. Our distance is our velocity, which is 5.0 meters per second, times the time, which is 0.78 seconds. And we're just left with meters. And that works out to be 3.9 meters. Okay? Now, some of you may have been tempted to use a different formula, and I just kind of want to kind of note this. Some of you may have been tempted to use, so we found the answer to be x is equal to 3.9 meters, okay? So, some of you may have went to the formula sheet and tried to use the formula that deals with the range, okay? Since we're having something with projectile motion, okay, and we know that the range is basically the distance that a projectile travels in the x direction. And so some of you may have been tempted to identify this particular problem with the range. And with the formula that's given on the formula sheet, you have range is equal to your initial velocity squared times the sine of 2 theta, your initial angle, divided by g. And you say to yourself, well, we know the initial velocity, right? That was 5.0 meters per second. So we know that. And we do know the initial angle. The initial angle, there is no y component, so the initial angle basically is 0. So we know that theta sub 0 is 0. And we know gravity, which is 9.8 meters per second. So if we just substituted in this information for the range, we should get the answer, right? So if we put in 5.0 meters per second, we needed to square that, and then we take the sine of 2 times 0 and divide that by 9.8 meters per second squared. Do we get 3.9 meters? Well, we know that on the numerator we're going to get 0 here, and 0 times anything is going to give us 0, so we actually get the range to be 0, which does not equal to 3.9 meters. So you ask yourself, what's the problem? Okay, the problem is that this is not the correct formula. Okay, this is only true if your initial height is equal to 0. All right? And in our particular problem, the way that we had our coordinate system set up, remember our coordinate system was the positive x in this direction, positive y in that direction. Well, our initial y was equal to 3 meters. Okay? It did not equal to 0. And so this equation only applies only if our initial y is equal to 0. Okay? In fact, when our initial y is different from 0, does not equal to 0, we would actually have to use this equation. That's the range now is equal to okay? So our new equation for the range when the initial y does not equal 0 is actually this equation. And if we were to substitute in the information into this equation, we know that this term is going to go to 0 because theta is equal to 0. We also know that this term is going to go to 0. So basically our range is just equal to, and this term is going to equal to 1, so that's going to be our initial velocity multiplied by g, or divided by g, I'm sorry, the gravity, and that's going to be multiplied by the square root of 2 times the gravity times delta y. Y sub 0. And if we put in this information into the range, we indeed get 3.9 meters, which is exactly equal to what we found doing it the other way. So I just wanted to make a quick note that you would have been misguided and incorrect to use the equation given for the range, given the fact that this is only true when your initial y is equal to 0. Okay? So that's it.
The Teaching Center, UF's Learning Support Center, www.teachingcenter.ufl.edu.